chapter, we would like to talk about reactivity of metals. When we talk about reactivity of metals, we find some metals are more active in the reaction than others, so that's why in chemistry we use the term more reactive, such as potassium is more reactive than gold if we compare their behavior in water. So that's why we can say reactivity means the readiness of the metals to react with other substances. Later on, we will talk about reactivity series. Actually, it is constructed by comparing the reactivities of metals and then they are arranged in an order. I'll let you take a look of the reactivity series. So this is the normal way we show the reactivity series. It starts from the most reactive metal at the topmost position, for example, potassium. And then when we go downward the reactivity series, the reactivity decreases. That means sodium is less reactive than potassium, calcium is less reactive than sodium, and etc. So that's why in this reactivity series, gold is the least reactive. Of course, when we compare reactivity of metals, we have to consider some factors and we make comparison based on these factors. You may wonder, what are these factors? In the first part, let's review the relation between extraction method and reactivity series. If you remember, this part is the extension part you learned in Form 3. Okay, let's recall. In Form 3, from the experiment, we find that the more reactive metals, such as potassium, sodium, calcium, they are most difficult to be extracted. On the other hand, the least reactive metals, such as silver, platinum, gold, they can be extracted most easily. So that's why we can see the ease of method to be used to extract different metals. You may wonder why the most reactive metals are the most difficult to extract. It is because when the metal form compounds, the compounds are very stable, and that's why you have to supply large amount of energy to break down the compound and extract the metal. Electrolysis is one of the examples which provide large amount of energy to break down the compound. For the metals in the middle of the series, such as zinc, iron, this metal can be extracted by carbon reduction. Of course, for the metals with much lower reactivity, such as copper, mercury, silver, when you discover them in the metal ore, they exist as compounds, except gold, platinum. For those very unreactive metals, even they exist as compounds. You can extract them very easily by heating the ore, that means heating the compound, unknown. because they decompose very easily and we can get back the metal. In the school laboratory, we can try to do an experiment of displacement reaction to extract the very unreactive metal from their solutions. This part will be discussed later. For the least reactive metal, such as gold, platinum, they exist as free elements. That's why we just need to use mechanical method to extract them. For example, gold panning. When we find the gold ore, we just need to break the rock and get the gold directly. So the first factor we come up is the ease or difficulty of metals extraction from their ores. The more reactive metals are extracted using more difficult methods involving higher technology. So this is the first factor for comparing reactivity of metals.